Okay, so adding and subtracting rational expressions are a little bit more complicated than the multiplication or division if you have unlike denominators. If you have like denominators, it's actually pretty simple. But I'm actually not going to focus on like denominators here because I figure most of you can handle those. Alright, so let's take a look. Here I've got three rational expressions. 2x over x plus 4 added to 10 over x plus 4 and then minus 2 over x plus 4. Now, since these all three have the same denominator, then I can just combine the numerators, 2x plus 10 minus 2. And of course, 2x plus 10 minus 2, when you do 10 minus 2, you get 8. So that's just going to be 2x plus 8 for the numerator. And then the denominator is just the single denominator, x plus 4. Now, one thing you always want to do when you add or subtract a rational expression is see if it will simplify, kind of like what I did at the beginning of the last section. So here, notice I have in the numerator 2x plus 8, but notice I can factor a 2 out of the numerator, and I get 2 times x plus 4. And now I know that x plus 4 up here, since that's a factor, will cancel with x plus 4 down here. And so that'll give me x plus 4 over x plus 4 is 1, and then 2 times 1 would simply be 2. So that would be 2. Now, what about unlike denominators? Well, let me show you what we have to worry about. First of all, with unlike denominators, you want to factor each denominator and numerator and look for common factors that may cancel. So you're going to do that first. Now, if anything will cancel, then you can cancel and then move on. I think on my examples, the step number 1 is really not utilized much because I don't give you any that would cancel before you start adding or subtracting. But then you want to determine the lowest common denominator. And then once you determine what that lowest common denominator, that's the expression that will divide into each one of your denominators. You want to, that each one of your denominators will divide into. And then you want to write each fraction using the lowest common denominators, and then you want to combine the fractions. Now, once you have your lowest common denominator, when you combine the fractions, the denominator will not change. So just keep that in mind. Alright, so let me show you an example here. This is my first simple example here with unlike denominators. So here I have 2x over x minus 1 plus 5 over x. Now this is plus, okay, it's not times like we were doing in the previous section. So now I need a denominator that both x minus 1 and x will divide into. Well, they'll both divide into their product. So I'm going to use the product of x times x minus 1. So many times the lowest common denominator will just be the product of those two, but not always. Alright, so x times x minus 1 is going to be the denominator. Now, I have to decide on each of these fractions, how can I make this fraction, like for instance, how can I make this fraction have a denominator of x times x minus 1? Well, if I multiply the denominator by x, then it would have a denominator of x times x minus 1. But if I multiply the denominator by x, I must also multiply the numerator by x. So what I have to do in this first fraction is just multiply it by x over x. So that's what I did here. I'm going to multiply the first fraction by x over x. Now, what about the second fraction? Well, the second fraction, the denominator is x. So if I want to make that look like x times x minus 1, I have to multiply the denominator by x minus 1. And of course, if I want to multiply the denominator by x minus 1, I also have to multiply the numerator by x minus 1. Okay, so here you can see I'm going to multiply the numerator and denominator of that fraction by x minus 1. Okay, so now let's go ahead and multiply the numerators together. So I have 2x times x, which is 2x squared. over x times x minus 1. There's really no reason to try to multiply these together at this point. Okay, and then I have 5 times x minus 1, which is 5x minus 5 over the denominator. See, now I have the same denominator for both fractions. So once I get the denominators the same, I can add the two fractions and the denominator won't change, so I'll just carry that denominator over and then I'll combine the numerators. So I have 2x squared plus 5x minus 5 for the numerator. Now, normally I would see if this would factor, but I didn't find any factors of this that would cancel with any factors down here. But at the end, you always want to check and see if the final answer can be reduced further. Okay, I have an example or two of that I'll show you in a minute. Okay, so here's a subtraction problem, and notice I have unlike denominators. See, this one's x minus 4, and this denominator is x plus 4. So I can just use their product, x minus 4 times x plus 4, as the lowest common denominator. Now, so that means I'm going to have to take this fraction in order to get it to have the same denominator. Since I have x minus 4 down here, I know I'm going to need a factor of x plus 4, so I can multiply this fraction by x plus 4 over x plus 4, and that will give me the common denominator, x minus 4 times x plus 4. And technically, by doing this, it doesn't change the value, because if you think about it, x plus 4 over x plus 4 is really just 1. Okay, and then for the second fraction, since I'm missing the x minus 4, I'll multiply this fraction by x minus 4 over x minus 4. Okay, now again, don't multiply the denominators together. Just carry the x minus 4 and x plus 4 to the next term. Now, I went ahead and gave you this step, but you could actually bypass this step and go straight to this step over here. But basically what I have to do is I have to multiply x plus 2 times x plus 4 together, which I'll do here with the FOIL method, and then I have to multiply x plus 3 times x minus 4 together here. So now if you FOIL this, you're going to get x squared plus 4x plus 2x, which is going to be 6x, and then 2 times 4 is 8. So you're going to have x squared plus 6x plus 8. And then if you multiply x plus 3 times x minus 4, you're going to get x squared minus 4x plus 3x, so you're going to x squared minus x, and then 3 times minus 4 is minus 12. Now, notice I'm just going to carry the denominator with me everywhere I go. Now, you got to distribute this minus. Remember, this was subtraction, so this subtraction has to be distributed through here. So I'm going to just change all these signs. So that's going to be minus x squared plus x plus 12, changing all the signs. Now notice that if you take x squared and minus x squared, that's going to be 0, so they cancel. And then 6x plus x is 7x, and 8 plus 12 is 20. So I get 7x plus 20 in the numerator, and then x minus 4 times x plus 4 in the denominator. And that's as far as I can take that. As far as simplifying that, that will not simplify any further. I suppose you could multiply these together, but again, I don't really worry about that. I just leave it in factored form. Now on this example, when you first look at it, it looks a little bit daunting here, because in this fraction I have x squared minus x minus 12, and this fraction I have x squared minus 7x plus 12. So if you factor these trinomials, you'll actually begin to see a way to get your lowest common denominator. So notice in the next step I went ahead and factored these. X squared minus x minus 12 factors into x minus 4 times x plus 3, and x squared minus 7x plus 12 factors into x minus 4 x minus 3. So my lowest common denominator, I need something that x minus 4 will go into, I need something x plus 3 will go into, and I need something x minus 3 will go into. So that would be the product of all three of those. So the lowest common denominator would be all three of those. Now, in this first fraction, I'm only missing the x minus 3. So I can multiply that fraction by x minus 3 over x minus 3 to get the common denominator. And in the second fraction, I'm missing the x plus 3. So I'll multiply that fraction by x plus 3 times x plus 3. And then when you distribute here, you have 5x squared minus 15x, which is actually, I did that down here. And then you distribute here, and you get 6x squared times x plus 3, which is actually, since you're distributing the minus, it's going to be minus 6x cubed minus 18x squared. And so that's what that's going to be. And notice I just bring my common denominator along here. Now just collect like terms. So I have minus 6x cubed, and then I have minus 18x squared plus 5x squared. That's going to give me minus 13x squared, and then minus 15x. Now what I could do here is I could factor out a negative x out of this. So factor a negative x out of this, and I get 6x squared plus 13x plus 15, and that's as far as I can simplify that. Okay, you can check this to see if it'll factor, but I don't believe it will factor. Okay, so the next one here, I have x minus 2 for a denominator, x plus 2 for a denominator, x squared minus 4 for a denominator, but x squared minus 4 factors into x plus 2 to x minus 2. Well, since this factor is the product of these two denominators, then I can just use x plus 2 times x minus 2 as my common denominator. So on the first fraction, x minus 1 over x minus 2, I need to multiply it by x plus 2 over x plus 2, so I have the denominator x minus 2, x plus 2. And the second one, I have to multiply it by x minus 2 over x minus 2, so I have the factors x plus 2 times x minus 2 in the denominator. And in the third one, I don't have to do anything because it already has the lowest common denominator. Now I'm going to speed this one along a little bit, but let me just tell you here, you're going to FOIL these, and you're going to FOIL these, and so you're going to have x squared plus x minus 2 minus the quantity x squared minus x minus 2, and then you're just going to add the x minus 6 to it. Okay, so you distribute the minus, and you collect your like terms, and you should get 3x minus 6 here. And you're just going to carry that denominator that we're using along each time. Now remember, I told you you always want to factor out the common factor and see if anything will cancel. So I'm going to factor a 3 out of the numerator, and I get 3 times x minus 2. Well, then x minus 2 over x minus 2 is 1. So the final answer is just 3 over x plus 2. And that's as far as you can take that one. Okay, so I'm kind of running low on time, so I'm just going to summarize this one. On this one, you have a trinomial here in the denominator and a trinomial here in the denominator, but these will factor into 2x plus 3 and x minus 1 for the first fraction, and 5x plus 2 times x minus 4 for the second fraction. So you know you're going to need a 2x plus 3, an x minus 4, and a 5x plus 2 for your common denominator. So now, since the first fraction doesn't have the 5x plus 2, we would multiply it by 5x plus 2 over 5x plus 2. And since the second fraction doesn't have the 2x plus 3, we would multiply it by 2x plus 3 over 2x plus 3. And then when you FOIL the products in the first fraction in the numerator, you get 15x squared plus 26x plus 8. And then when you multiply 2x minus 3 to 2x plus 3, you get 4x squared minus 9. And then distribute the minus and collect like terms here, and you'll get 11x squared plus 26x plus 17, and then over the three factors for the common denominator. And that is as far as you can reduce this fraction. I tried to factor this, but it wouldn't factor. So I couldn't get it to factor into anything that would cancel with any of the factors in the denominator. So anyway, that completes the section on adding and subtracting fractions. And in the next section, we'll talk about what's an item called complex fractions, where you have fractions in the numerator and fractions in the denominator.